What is a black hole? A black hole is a place in space where gravity pulls so much that even light cannot get out. The gravity is so strong because matter has been squeezed into a tiny space. This can happen when a star is dying. Because no light can get out, people can't see black holes. Space telescopes with special tools can help find black holes. The special tools can see how stars that are very close to black holes act differently than other stars. How big are black holes? Black holes can be big or small. Scientists think the smallest black holes are as small as just one atom. These black holes are very tiny but have the mass of a large mountain. Mass is the amount of matter, or stuff, in an object. Another kind of black hole is called stellar. Its mass can be up to 20 times more than the mass of the Sun. There may be many stellar mass black holes in Earth's galaxy. Earth's galaxy is called the Milky Way. The largest black holes are called supermassive. These black holes have masses that are more than 1 million suns together. Scientists have found proof that every large galaxy contains a supermassive black hole at its center. The supermassive black hole at the center of the Milky Way galaxy is called Sagittarius A. It has a mass equal to about 4 million suns and would fit inside a very large ball that could hold a few million Earths. How do black holes form? Scientists think the smallest black holes formed when the universe began. Stellar black holes are made when the center of a very big star falls in upon itself, or collapses, and when this happens, it causes a supernova. A supernova is an exploding star that blasts part of the star into space. Scientists think supermassive black holes were made at the same time as the galaxy they are in. Could a black hole destroy Earth? Black holes do not go around in space eating stars, moons and planets. Earth will not fall into a black hole because no black hole is close enough to the solar system for Earth to do that. Even if a black hole the same mass as the Sun were to take the place of the Sun, Earth still would not fall in. The black hole would have the same gravity as the Sun. Earth and the other planets would orbit the black hole as they orbit the Sun now. The Sun will never turn into a black hole. The Sun is not a big enough star to make a black hole. Who discovered black holes? Black holes were predicted as an exact mathematical solution to Einstein's equations. Einstein's equations describe the shape of space around matter. The theory of general relativity connects the geometry or shape of shape to the detailed distribution of matter. The black hole solution was found by Karl Schwarzschild in 1915, and these regions, black holes, were found to distort space extremely and generate a puncture in the fabric of space-time. It was unclear at the time if these corresponded to real objects in the universe. Over time, as other end products of stellar death were detected, namely, neutron stars seen as pulsars, it became clear that black holes were real and ought to exist. Black hole facts. If you fell into a black hole, theory has long suggested that gravity would stretch you out like spaghetti, though your death would come before you reached the singularity. But a 2012 study published in the journal Nature suggested that quantum effects would cause the event horizon to act much like a wall of fire, which would instantly burn you to death. Black holes don't suck, and suction is caused by pulling something into a vacuum, which the massive black hole definitely is not. Instead, objects fall into them just as they fall toward anything that exerts gravity, like the Earth. The first object considered to be a black hole is Cygnus X1. Cygnus X1 was the subject of a 1974 friendly wager between Stephen Hawking and fellow physicist Kip Thorne, with Hawking betting that the source was not a black hole. Miniature black holes may have formed immediately after the Big Bang. Rapidly expanding space may have squeezed some regions into tiny, dense black holes less massive than the Sun. If a star passes too close to a black hole, the star can be torn apart. Astronomers estimate that the Milky Way has anywhere from 10 million to 1 billion stellar black holes, with masses roughly 3 times that of the Sun. Black holes remain terrific fodder for science fiction books and movies. Check out the movie Interstellar, which relied heavily on Thorne to incorporate science. Thorne's work with the movie's special effects team led to scientists' improved understanding of how distant stars might appear when seen near a fast-spinning black hole. One star's end is a black hole's beginning. Most black holes form from the remnants of a large star that dies in a supernova explosion. Smaller stars become dense neutron stars, which are not massive enough to trap light. If the total mass of the star is large enough, about 3 times the mass of the Sun, it can be proven theoretically that no force can keep the star from collapsing under the influence of gravity. However, as the star collapses, a strange thing occurs. As the surface of the star nears an imaginary surface called the event horizon, time on the star slows relative to the time kept by observers far away. When the surface reaches the event horizon, time stands still, and the star can collapse no more. It is a frozen collapsing object. What would happen if we fell into a black hole? If you leapt heroically into a stellar mass black hole, your body would be subjected to a process called spaghettification. No, really, it is. The black hole's gravity force would compress you from top to toe, while stretching you at the same time. Thus, spaghetti. A supermassive black hole has a slightly less horrendous effect. So let's imagine then that you opt for one of these to make your giant leap for mankind and scientific research. Your journey into Sagittarius A itself would begin after you slip over the event horizon, the point of no return. You would be able to see out from inside, but no one would be able to see you because any light would fall back on you. The good news is that although the gravitational pull is much stronger than smaller black holes, the stretching tidal force is less, meaning you won't be turned into spaghetti. But the bad news is you wouldn't be able to get out. What do black holes look like? Black holes have 3 layers: the outer and inner event horizon, and the singularity. The event horizon of a black hole is the boundary around the mouth of the black hole, past which light cannot escape. Once a particle crosses the event horizon, it cannot leave. Gravity is constant across the event horizon. The inner region of a black hole, where the object's mass lies, is known as its singularity, the single point in space-time where the mass of the black hole is concentrated. Scientists can't see black holes the way they can see stars and other objects in space. Instead, astronomers must rely on detecting the radiation black holes emit as dust and gas are drawn into the dense creatures. But supermassive black holes, lying in the center of a galaxy, may become shrouded by the thick dust and gas around them, which can block the telltale emissions.